My name is Lowen Singh, and today our group will introduce about the Chinese Lunar Exploration Program. Chinese Lunar Exploration Program, also called Chang'e Project, and it is the most ambitious space exploration program in the world today. So the journey started in the year 2000 when lunar explorations was the first included in China National Space Development Plan. And by 2004, the program was officially approved, launching a mission that would gradually change our understanding of the lunar. And the Chang'e project also follow a step-by-step plan, which is orbiting, landing, sample return, and the future. In 2007, China has took a historic leap with the launch of Chang'e-1, the pioneering phase of our lunar exploration program. So by successfully orbiting the moon, the mission didn't more than just test our space technology. It also provides the data of the lunar surface and also composition that scientists still rely on today. So Chang'e-1 wasn't just a technical success, it was a foundation for our deep space ambition and also transforming the China from a dreamer into a key player in lunar science. So now I will talk about the purpose.
The Chang'e-1 mission
is China Lunar Exploration Program. It includes an orbiter. The main purpose of the satellite is to carry out scientific research on the moon. Let the country to understand the physical and chemical properties of the moon.
This satellite is used to obtain three-dimensional image of moon surface
and explore the topography.
Also can use to analyze the distribution and abundance of chemical elements. This satellite is used to investigate the thickness of the moon's soil and space environment.
Next is technology development. This satellite is used to test and demonstrate new. This included precise orbital maneuvers,
Earth-Moon transfer orbit design, long-distance communication,
and remote sensing technology. This satellite will not only contribute to the accumulation of scientific knowledge and also aid in the development of future lunar exploration missions. This satellite can improve image resolution
and obtain global mapping data. This satellite can use to produce detailed maps of the moon surface and selection of landing sites for
subsequent missions. Information gathered is also going to help us understand the formation and evolution of the moon and its relationship to the Earth. Finally, the satellite has both scientific and technological significance in helping us know more about the moon and how further explore it and advance China's capabilities in space exploration.
Hello, my name is Chang'e-1, and now I will explain the working mechanism. First, the mission starts by launching a spacecraft from Earth using a launch vehicle. The spacecraft is sent into an Earth-Moon transfer orbit, which allows it to travel from Earth toward the Moon. As it moves closer to the Moon, the spacecraft makes small adjustments to its direction and speed. This helps it stay on the correct path and reach the Moon safely. Before entering lunar orbit, the spacecraft must slow down. This is called a braking maneuver. It allows the spacecraft to be pulled in by the Moon's gravity and enter a stable orbit around the Moon. For missions on the far side of the Moon, communication becomes a big problem. This is because the Moon blocks the radio signals, so direct communication with Earth is not possible. To solve this problem, relay satellites such as Chang'e-2 are used. These satellites are placed in special positions in space so they can stay in contact with both the spacecraft and the Earth. This allows data to be sent back in real time and the mission can be monitored continuously. Overall, the mission includes many stages such as launch, landing, exploration, communication, and return. Each step must be done very carefully and accurately to make sure the mission is successful.
And now I will present the notable contribution of Chang'e-1 lunar probe. As China's first lunar orbiting mission, Chang'e-1 achieved significant accomplishment in both engineering technology and also scientific discovery. In terms of engineering and technology, Chang'e-1 established China's capability for precise orbit determination in deep space exploration. Based on its tracking data, the research team developed the CEGM-02 Lunar Gravity Vibe Model, the first such model derived from Chinese mission data, and estimate the lunar tidal love number, providing important construction for studying the moon's deep interior structure. The orbital accuracy achieved during the orbiting pass, approximately 200 meters, set a critical benchmark for all subsequent lunar and deep space exploration. During data processing, researchers also identified a deceptive horseshoe thread in the residue, a phenomenon that disappears with the upgrading of China's deep space network, offering valuable insights for system optimization. At the end of its mission, Chang'e-1 successfully executed a controlled impact on the lunar surface, capturing 1,469 km of image prior to impact and validating key orbital maneuver technology for future landing and sample return missions. In terms of scientific discoveries, Chang'e-1 achieved several internationally pioneering results. The mission generated 1.37 TB for raw data, which were processed into 4 TB to scientific data produced, establishing China's first stateless data processing and distributed system for lunar exploration. The laser altimeter acquired 9.16 million range measurements, producing the first global digital evolution model of the moon with full polar coverage. The gamma-rich spectrometer met the global distribution of 14 key elements, including potassium, thorium, and uranium. In summary, Chang'e-1 not only marked China's first steps into deep space exploration, but also provided scientific achievement and technological foundation that have paved the way for subsequent lunar and deep space missions.
And 可以 now like the our final part concluded. The Chang'e-1 mission represents an important lunar exploration. It has helped develop more advanced space technology and improve our understanding of the universe. In terms of technology, Chang'e-1 used an orbital system to circle the Moon and carry out scientific observations. The mission involved key technology such as precise orbit control, Earth-Moon transport orbit design, and long-distance communication, which improved the reliability of space missions. It successfully completed its planned lunar orbit and operated stably, laying a solid technical foundation for other Chang'e missions. In terms of scientific understanding, Chang'e-1 collected a larger amount of data on the Moon, including 3D imaging of the lunar surface and information on its chemical composition. Their data help scientists better understand the Moon's surface, the structure, and the environment, and also provide important clues about the early history of the Earth and the solar system. Therefore, the Chang'e-1 advanced space technology is also expands our understanding of the origin and the environment of the universe. In conclusion, the Chang'e-1 shows progress in space technology and help us better understand the Moon and the winter universe. As technology continues to develop, humans will have the opportunity to explore deep into space. Thank you for your watch.